Lesson 17.3, Task 5. Solve quadratic equations by factoring. An in-ground pool is being installed with a concrete path of uniform width on all four sides. The pool, along with the concrete path, will have a total area of 96 square meters. What is the width of the path? All right, so here's a picture, and you can see here's the pool, and it does have a path of equal width all the way around the pool. All right, so the area of the pool along with the concrete path can be modeled by multiplying the total length by the total width. So area, length, times width. All right, using a verbal model, the total length, okay, so here's the length of the pool. So you can see it's twice the width of the path. So here the path is on both sides of the pool. So we've got x and x again. So it's 2x plus 9 meters is the distance of just the pool. And then we're going to multiply that. So length times width. The width is going to be represented by x and x again on this side. So 2x for both sides of the path plus 5 meters is the width of just the pool. So the 2x plus 5 represents the path on each side with the pool included. So we know that the length times the width equals 96 meters squared. All right, to write that as an equation, you're just going to take this and put it as one factor, and this will be your second factor. Length times width equals 96. We know to multiply because we know the formula for area of a rectangle. All right, so to solve this, you're going to first multiply your binomials using distributive property and then subtract 96 to set it equal to 0. All right, so anytime we're solving a quadratic equation, A, B, and C have to be on the same side. This is called standard form. When it's in standard form, it's easier to graph, it's easier to factor. Later, you're going to see there's a couple more ways to solve, and it will need to be in standard form, okay? All right, so once they put it in standard form, then they made a table of values, factored it, and then set each factor equal to 0 using the zero product property. So x equals 1.5, 3 halves is 1.5, or negative 17 over 2. Now, this answer is not going to be reasonable because we're looking at length times width. Both of these are distances. All right, so we can't have a negative x because that would make that a negative length or a negative width, and that just would not work. So we only have one good answer there, which is 3 halves. All right, so it says for which equation can you apply the zero product property? All right, so set it equal to 0, and then once you set it equal to 0, then you can use the zero product property here in this step. So it would be when you have factors equal to 0, that's when you can use the zero product property. What strategy and tools can you use to factor the quadratic expression? All right, so you can do what I do, which is A times C, add to get B, or you could make a table of values with all the multiples of A, all the multiples of C, and then all the different combinations that add up to give you the middle term, which is B. So whichever method you prefer, then you can do that. All right, it says choose the correct words to complete the statement. The solution x equals negative 17 over 2 is not a valid solution because x represents the width of the concrete path, and that cannot be a negative number. All right, so it says answer the question. The width of the concrete path is 3 halves or 1.5 meters. All right, complete the statement. The area of the concrete path is blank meters squared. All right, so if we look at what we have been given, okay, we can go back and let's write down what we are given. All right, so we know that 2x plus 9 times 2x plus 5 equals 96. All right, we also know that just the pool just the pool itself is 9 times 5. Length times width of the pool is 45 meters squared. So we've got to find what is the distance of the concrete. So what we're going to do is, now that we know that x is 1.5, you can simply plug in 1.5. So we can do 2 times 1.5 plus 9, and then we've got 2 times 1.5 plus 5, and all of that still should equal 96. So we can check and see. So 2 times 1.5 would be 3 plus 9, and then that would be 3 plus 5, and what we're doing is this 96. So 3 plus 9 is what, 12? And then that's 8. 8 times 12 is 96. So we know that the total area is 96 minus the area of the pool, and that leaves the area of the concrete path. So if you do 96 minus 45, the area of the pool is 51 meters squared. So this should be 51 meters squared. All right, that's all for task 5. If you have any questions, let me know.